So now, let's have a look at something that does this. So this is a plot versus time of the motion of a particular object. You can tell me a number of things, in fact 3 things about its motion. Where would, if I wanted to plot a high negative velocity as just one point, where would I put it? Down here? Yeah? And if I wanted to plot a small negative velocity, where would I plot that? Higher up, like here. So now, because I know that this has got the shape somewhat of a parabola, I draw a straight line showing a continuously decreasing negative velocity. Since it's Halloween, I'll use orange. What is this one doing? Who's going to tell me the story about this particular one? Isabel? It's going towards, yeah? What's increasing? The speed is increasing, it's going towards, and is, what else can you tell me about it? At the end it's faster than the other one, yes it is. So if I wanted to plot it down here, how would I start? So it's going to be in the negative velocity region, and is the velocity initially high or low? If I drew a straight line here, and a straight line here, could you tell me which slope is bigger? The purple one, yeah, the purple one is bigger. So we want to start with a smaller value for the velocity, but in the negative region. So where would I put a smaller value for the velocity in the negative region?
Next to 0.
Next to 0, yes. There. And what can you tell me about the slopes down here, comparing the two? Would you like me to put lines in? So they're still now both negative slopes, aren't they? We could say steep and shallow. Do you know those 2 words? If I use the word steep and shallow, would that help? Which one of these is steeper? The orange one is steeper. So if this one is steeper, right, if it's steeper, where am I going to put it? I'm going to put it down here because it's bigger, right? I'm going to put it down there because it's bigger. Okay, so here's one that starts like that and it does that. Going away, increasing speed. If I was going to show going away, which region of the velocity time graph is it going to be in? In the upper region, right? If it's increasing, what can you tell me about the velocity at the beginning? It would start low, so that means that if I'm going to put a red dot on here, where am I going to put it? Closer to 0, yeah. And what am I going to do for the final velocity in this case? Where will that be? Because the slope is steeper, right? Put that there, like that. Now let's have a look at one more. Like that.
It's going away.
Yeah.
And it's slowing down as it goes.
And you know it's going away because?
Because it's going that way in the top right.
Okay.
Going higher.
Yeah. And how do you know that it's slowing down?
The curve or the slope is getting smaller as it goes.
The slope is getting smaller as it goes. So how would I plot this? How would I plot the beginning on this velocity time graph?
The first one would be in the upper left corner.
Yeah.
And the second one would be in the bottom right corner because it's slowing down.
Let's have a look at something else now, right? I'm going to throw you a curveball. What we're going to look at is that. Right? That, by the way, is a straight line, even though it doesn't look like it. I want to know what the position time graph for that looks like. Graham.
Oh, God.
Remember, what you do is you break it into pieces, right? So, what does this one look like? Does it look like anything else on there?
Yeah, it has a constant linear slope
and the bottom half is negative, so it's
So what is the object doing during this period? So the bottom slope, bottom part of the graph means,
towards, so it's speeding up and going towards.
okay, it's speeding up and going, so it's going very fast, right?
Oh, sorry, yeah, it's slowing down and going towards.
It's slowing down and going towards, that's correct. What happens here?
It changes directions.
Which means it?
It's going away now.
Yeah, but at this very instant here, what did it do if it changed direction?
Stop.
It stopped, exactly. So that means the slope on the position time graph at that point's got to be?
Straight line, 0.
0, exactly. So I can do a 0 here, right, like that, and this one is
Down.
negative, right,
Negative.
a negative slope. So I could draw this one here like that, right? And now what's happening? Tell me a story about what's happening here.
Going away.
It's going away, yeah.
Now it's increasing in speed, right?
Now it's increasing in speed, exactly. So what would I show for the third point for this?
It would go somewhere along like the red line, right?
Right, right, it's a positive slope getting steeper. And so now if I do that, I can join them, right? Let's do one more and then we're going to talk about a real life situation. I'll do this one dotted. What is this dotted line telling us about the motion of an object? Well, let's have a look. It's in the velocity time graph, right? And what do we know about the two regions of the velocity time graph?
One's away and one's close.
Right, so what can you immediately tell me about the object before going any further? Yeah, it goes away and then it comes back again, right? And what happens at this point here? It stops, exactly. So I'm looking at this one here. So, right, the dotted one, what is that saying to me in this region here?
It's moving away.
Moving away. Is it going fast or slow?
It's going,
So it's fast here.
yeah, and so
And what's it doing here?
it stops.
It stopped. And then down here,
It's fast again.
it's fast again. And which direction?
Towards.
Towards. So what we're told is we have a high speed initially going away, right? Which converts into a positive slope, steep, right? And then we're told that it's 0. There's a 0 slope. And then we're told that it's large and
Oh, towards.
towards, which is, we also use the word,
Negative.
it's negative, yeah. You see this graph here? Away, towards, negative velocity, positive velocity. Okay, so what we're going to do is we put a large one like that. So now when we look at that, what we see is something that's doing that. Position versus time. Is it going up? It slows down, turns around and comes back. In this classroom, if I was to demonstrate motion of an object that follows that description, what would I do? What's the very simplest thing I could do without moving from where I am? Anyone? Yeah?
Toss something and then have someone toss it back.
Yeah?
You could just toss it straight in the air and it would come back of its own, right?
Yeah. That's exactly what I can do. I do that, comes back. At the top, it's stopped, right? At the top, it's stopped. At the beginning, when I set it up, it was going much faster, right? It slowed down. And then it started speeding up as it came back down to my hand. So, these aren't just a mathematical exercise. They're actually a picture describing what we can see. We can look at some more complicated things as well. But first of all, let me teach you a little trick that I use when I'm wanting to move from position time to velocity time, because it's actually a little counterintuitive that you can get a straight line from a curve. The slope of a parabola is continuously changing, and the slope is actually will form a straight line. So if I have a position time graph that looks like that, and I want to make the velocity time graph, what do I do? Well, my little trick is I actually put in some little slopes, just like I was doing over there. So I put that slope in, this slope in, and this slope in. That's a 0 slope. So I immediately know that it's going to go through 0. This is a negative slope. It must be in the negative region. And it's quite steep, so it's large. And large, as we know, means further away from the origin. We come onto this side. So you've got this is now a very steep positive slope. This is the positive region. Very steep means a large velocity. So I'll stick that there. And that's my line. If I do the same with this one, I have a slope, and a slope. 0 here. So I know that this one's going through 0 too. But now what have I got on this side? I have a large, what sort of slope? Large positive, exactly. So I can do large positive over here. And what have I got on this side? Large negative. You're getting it. And that's what that one looks like. Very counterintuitive. We can also add these things together. And I'll do one more to show you how we do that. And we can go back the other way as well. This is plus velocity minus velocity. That's 0. This is time. Okay. Watch this one. Oh my God, I heard. So we're going to do the same thing, right? We're just going to stick in our slopes. There's one slope, almost 0, right? Here's another slope, right there. And here's another slope right here. This is close to 0. Okay, let's put in 0. And this is what sort of slope? Large and negative. Right. Comes down here. And what's this slope?
0.
Close to 0. In fact, if you look at it, this is made up of 2 of these other curves. Let's do... All right, so what am I going to do? I'm going to put in the slopes. I put a slope here, I put a slope here, and I put a slope here. What can I say about this slope here?
0.
Sorry?
It's almost 0.
It's almost 0, so I've got a point here. What can I say about this slope here?
0.
It's almost 0. This slope is?
Positive.
Large and positive. It's up here. Other ones, I could do this, right? Again, it's simple. What we're going to do is analyze it, right? So we take this, we've got that slope there, right? What sort of slope is that again? Large and positive, right? And this one here?
0.
Close to 0. And this one here? Large and positive. So it stayed large and positive, it finished large and positive, but it went to 0. Isn't there a beautiful symmetry to this? Can you see the symmetry? If we do one more, hopefully we'll complete the cycle. We'll do this one here, right, like that. Again, what we'll do is we'll put in the slopes. We've got a large slope here, we've got that slope there, this slope here. What can you tell me? What's this first slope? It's
Large negative.
large negative. What's this final slope?
Large negative.
And this is
0.
0.